Hello everyone. In this video we're going to configure inter-VLAN routing across multiple routers and switches in a router on a stick deployment. We're going to create 4 VLANs, VLAN 10, 20, 30 and 40, with VLAN 10 and 20 residing in one network, while VLANs 30 and 40 will reside in a completely separate network. So the first thing we're going to do is to lay down our network infrastructure. We're going to pick 2 routers and 2 switches. Finally, we will pick 4 PCs actually, and we're going to put them into the 4 VLANs. Next, we're going to deploy the cabling. So a copper straight through cable from the PC in VLAN 10 to the first switch to port 01, and then another one from the second PC of VLAN 20 to port 5 of the switch. Then we will connect the switch from its last fast Ethernet port to the Gigabit Ethernet port of 0/0/0 of the first router. We're going to do exactly the same in the other network. And we are going to connect the 2 routers with a copper crossover cable, connecting them both on port 0/0/1. Excellent. So the first thing we need to do now is to configure our switches, starting with the one on the left. So we will navigate to its CLI and run enable conft VLAN 10. We're going to name it IT. And we will also create VLAN 20 and name it finance. And I will actually make a note of that, so I will say IT and finance. Okay, then I will go into fast Ethernet 0/1, which is connected to VLAN 10, and I will run switchport mode access and then switchport access VLAN 10. Okay. Next, we will go into fast Ethernet 0/5 port, and we will run exactly the same commands. We will make it an access port, and we will make it access VLAN 20. And last but not least, we will enter interface fast Ethernet 0/24, which is the port connected to the router, and we will make that one a trunk port. Verify. Okay, we can see our 2 VLANs have been created successfully, and we will also save the changes. And then we will go over to our second switch, navigate to its CLI, run enable conft VLAN 30. We're going to name it HR, and VLAN 40, which is going to be named sales. So HR and sales. Excellent. Okay, next we will move into fast Ethernet 0/1, which is connected to VLAN 30. Switchport access mode access, and then switchport access VLAN 30. Next, fast Ethernet 0/5 port, switchport mode access, and switchport access VLAN 40. And finally, last port 0/24, which is connected to the router, switchboard mode trunk. And I believe we are done with the configuration of our second switch. Save the configuration. And now we will configure the two routers, starting with the one on the left. We will navigate to its CLI, type no, enable conft, and I believe it's the 0/0 interface connected to the network. So we will do 0/0/0.10, which is going to be the sub interface for VLAN 10. Encapsulation .1q10, and then IP address 192.168.10.1, followed by a /24 subnet mask, like so, and then no shutdown. Similarly, we will create another sub interface .20, encapsulation .1q20, and then IP address 192.168.20.1, followed by a /24 subnet mask, and no shutdown. Okay, and then we will have to configure the interface of the router connected to the other router, and this can be really anything. To keep it simple, let's just do 1.1.1.1/24. Well, the network itself could be 1.1.1.0/24. So we will do 0/0/1, which is the correct interface, and then we will do IP address 1.1.1.1 255.255.255.0, and no shutdown. And we will also do the same on the parent interface of 0/0/0, no shutdown. Okay, and we will commit the changes to memory, and we should be good to go with our first router. Let's just put .1 there and .2. Okay, so we are now inside the CLI of our second router on the right hand side. Enable conft interface should be 0/0, which it is, .30, encapsulation .1q30, and IP address 192.168.30.1 255.255.255.0, no shutdown. And same for VLAN 40, we will create a new subinterface .40, then do encapsulation .1q40, and then IP address 192.168.40.1 255.255.255.0, no shutdown. And we will also do a no shutdown on the parent interface to bring them all up. And then we will move into the interface connected to the other router, do IP address 1.1.1.2 255.255.255.0, and no shutdown. Okay, excellent. Finally, we will commit the changes to memory. Okay, let's do some testing. If I go into simulation and enable only ICMP, And then I try to ping, let's say, from the PC in VLAN 10 to the PC in VLAN 30. Oh, my fault. We actually forgot to configure the network settings of the 4 PCs. So we will do 192.168.10.10 and then .1 for the IP address of the default gateway for VLAN 10. So this one will be 192.168.20.10 and .1 for the gateway. The IP address of the PC in VLAN 30 will be 192.168.30.10 and last but not least, the PC of VLAN 40 will have an IP address of 192.168.40.10 and .1 as the IP of the default gateway. Okay, we will fast forward the time. And now let us try to carry out our simulation by performing a ping from the PC in VLAN 10 to the PC in VLAN 30. As soon as the packet, we can see that as soon as the packet reaches the first router connected to VLAN 10, the packet gets discarded. This is because this router doesn't know yet of VLANs 30 and 40. We haven't configured it to know any of these two networks. To make this work, we need to go back to this router and type const IP root and specify the two networks, which are 192.168.30.0 with a subnet mask of 255.255.255.0 and then specify 1.1.1.2, which is the IP address of the next hop router. And we're going to do exactly the same with the 40.0 network. If I do show IP root, we now see that we have two static routes for the remote VLANs. Okay, so we will carry out the same test again by running a ping from the PC in VLAN 10 to the PC of VLAN 30. And let's see what happens this time. So we can see that the packet is flowing through the first switch, through the first router, and then the second router forwards the traffic to the PC, which is sending back its ICMP reply. But now the traffic gets discarded on the second router because the second router doesn't have any knowledge of these two networks. So to fix that, we need to go back into real-time mode and into this router. Run enable const and then IP root 192.168.10.10 255.255.255.0, which is the subnet mask of that network, and then 1.1.1.1, which is the IP address of the next hop router, which is this one. Inconsistent address and mask. IP root, I made a mistake, I think. Oh, yep, my bad. I should have typed 192.168.10.0. Yes. And then 20.0. show IP route, and we can see that we now have two static routes for both of these VLANs. Write the changes to memory, fast forward the time, and let us try to carry out the same test again. Okay, so from VLAN 10 to VLAN 30. Once more, it's flowing through the first switch, through the first router, over to the second router, which is in turn flowing the traffic to the switch. It reaches the PC in VLAN 30, and the PC in VLAN 30 is responding with its ICMP reply, and this time the traffic can make it all the way back to the origin, which is the PC in VLAN 10. If I delete that and we run the same test from, say, VLAN 20 and VLAN 40, I got a buffer full, clear event list. Okay, sometimes it takes a while for the change to take effect. I will fast forward the time again. And alternatively, we can also use the plain old command prompt. So if I do ping 192.168.40.10, we can see that we can ping the host in VLAN 40 from VLAN 20. And at the same time, we can obviously ping any host in any VLAN from any other VLAN as well. So I should be able to ping 192.168.10.10 as well as 30. And there you have it. So we have successfully configured inter-VLAN routing across multiple routers and switches. Thank you very much for watching.